Okay guys, so the last couple days we have focused on factoring polynomials, and we know lots of different ways to factor. Today we're going to focus on taking those polynomials and solving them, and that means when you solve an equation, that means to get x by itself, or figure out the value of x. So I have an example here of a polynomial. This is a quadratic. X squared minus 5x equals 14. Now if I didn't have that x squared there, if this was just 5x equals 14, this problem would be very easy. But the fact that I have an x squared and an x complicates things. This is a quadratic trinomial. I'm going to need to factor if I want to solve. In order to factor, I have to get 0 on one side. So I'm going to subtract the 14. And then split into my two parentheses. To get x squared, we got x, and we're going to multiply to 14, add to negative 5. So let's do minus 7 and plus 2. And then we take each of our factors, and we set them equal to 0. And I've got a solution of 7 and a solution of negative 2. And that's something that we spent a lot of time doing back in chapter 5. Something that's very similar to this is the process of finding the zeros of a function. And you're going to have to remember that zeros, those are just a fancy name for x-intercepts. And the y value of every x-intercept is 0. So if I take this function and I ask you to find the zeros, that means I'm asking you to find the x-intercepts, which means that the y value is 0. Now, when you look at this equation, initially you don't see a y, but you should remember that f of x represents y. And I just told you that the y value is 0. So I can plug a 0 in for y. And now I've got to find the x-intercepts. Well, that means I have to solve for x. So again, I'm going to have to try to factor this quadratic trinomial. A little more complicated with the 5x squared. I know I have to do x and 5x. I've got to multiply to positive 4 but add to a negative. That means these are both going to be negative. And if I do 2 and 2, this is going to get me negative 10x, and then negative 2x is negative 12x, so that works. And again, just like above, I take my factors and I set them equal to 0. And I solve for x. So we'll get 2 and 2/5. And those are my two x-intercepts. If I were to plot this equation, I would know that it crossed the x-axis at 2 and 2/5. So just to give you a visual on that, these are zeros. So we're crossing at 2, and 2/5 is just about right there. By the way, I also know this thing is opening up, so my quadratic probably looks something like that. Okay, but those are the zeros. Now, that is all review. What I want to do now is take things that are not quadratic, maybe they're cubic, maybe they're quartic, and be able to solve. So again, the key, not the key, the key to solving is to factor. If you look at this polynomial here, number 1, it's not quadratic, it's cubic. But just like a quadratic, if I try to factor it, I might be able to solve for x. I already have the 0 on one side, so that part's done. A couple days ago, I'd take a look at this equation and we would factor out the GCF, which is an x. And if you actually look at what you have, just this part is what you just factored up here. You just happen to have an x on the outside. Now you can't get rid of him, he's important. But I know that the rest factors like so. And just like before, how we took these two factors and set them equal to 0, now you take every single factor and set it equal to 0. So x equals 0, x equals 2, and x equals 2/5. On number 2 here. This one's a little different because we don't have 0 on one side, but that's the first thing I'm going to do. And I like to keep the biggest term, or the term with the biggest exponent positive. So I'm actually going to add the 4x squared over, add the 2x over, add the 8 over, and put the 0 on the right side. Although you don't have to do it that way. Now taking a look at this guy, he's also cubic, but he has 4 terms, and there is no GCF. This is an instance where it would make sense to factor by grouping. So I take out an x squared from the first term, and I'm left with x plus 4, and I take out a 2 from the next term, and I'm left with x plus 4. I have the same thing in each group, so I get to factor that away, and I'm left with x squared plus 2 is my other factor. And again, we take each of our factors and we set them equal to 0. So here I'm going to get negative 4. Over here, when I go to take the square root of that negative 2, I get plus or minus I root 2. So it's been a while. Oops, sorry, you might not be able to see that. It's been a while since we've encountered those imaginary numbers, but they can actually come up again when we talk about polynomials in general. You know, things that maybe even aren't quadratic could still have imaginary solutions. So it's something to be aware of. So we have a solution of negative 4 and 2 more solutions, positive I root 2 and negative I root 2. All right, and that's all we got for right now.